A very lovely hello to all champions once again with fabulous session in this live class. I would like to welcome you everyone. So before I proceed, before I start this session, this classic session for you all of the chapter, one of the favorite chapter of every physics, every NEET and JEE aspirants, and that is system of particles and rotational motion. I know guys, you love this chapter a lot. So before I start doing questions here, let me know everything is fixed. I'm audible to you all and I'm visible to everyone. You all have joined the session successfully and I know you must have been waiting for a long time. Yes, champions. So let me know you all are there. Everything is fixed. Live streaming is going on well. Yes, sir. Thank you, Shiva. Hi, Shiva. How are you, champ? So today is 22nd of April. Almost 10 days, hardly 10 days are left for your NEET exam. I know you must be worried about the exam, your preparation, the question paper and everything. A lot of different kind of things may be shuffling in your mind. What kind of question will be there? What if I'll not be able to score good in physics, in chemistry, in biology? What if I'll not be able to get good rank? Fine, sir. Thank you. So it happens, my dear champions. You don't need to be worried about the exam and all. Just stay confident, stay positive, calm, and whatever you guys studied so far, that is enough for you. You need to be very positive and very confident. This is the most crucial phase for any student. Okay. So let's begin this session here. Okay, so just to wait a little while, 1 minute more, so that other students can join. Yeah, so that you all can get advantage of this live class, because my intention is to give you quality questions that will genuinely help you out in your exam. So I have brought up, look at the level of question, my dear champion. Most of the aspirants stuck in solving such kind of questions. So I have brought up all the quality questions. So if you are not able to get the answer, my dear champion, you guys can just look at the screen at least. The way I am solving the question, that will be enough for you all. Okay, so this is the beauty of live class, my dear champion. If you guys can honestly solve all these questions that I brought up here in the live class, that is genuinely help you out in your exam on 3rd of May, champion. This is my assurance, and mark my words. So let's begin with question number 1. Sangeeta, hi Sangeeta. Hello to everyone, the student who have joined successfully, and all the student who have joined very first time in this live class, in my live session. My dear champion, stay here till the end and practice all the questions along with me. It would be very nice of you if you sit with your notebook and pen with me and solve along with me, my dear champion. Okay, because this is the final phase practice, final phase revision, my dear. You don't have a lot of time to do entire syllabus, and also this is very important to solve some PYQs, quality PYQs, and that is the reason why I have brought up these questions for you. Okay, so let's begin with this question without wasting a moment. Okay, who is this? Yeah. Okay, and the student who new here and the student who is watching this live class, go and press the like button. Go and hit the like button first. Press the like button, everyone. Don't forget to press the like button. Okay. So let's begin with the question number 1. Look at the question. This question looks very dangerous. Sir, option B is correct. Option B is correct. Okay. Let's wait, Shiva. I'm waiting for others' response. Very good. If you got your answer correctly, very good, Shiva. I'm waiting for others. Shiva is writing option number B. Okay. Very good question. Can you see, my dear? If I tell you one thing, this is JEE level question, but yeah, it has appeared in NEET exam in the year 2016, so you should solve the question. Very good question, but the approach should be clear. If your concept is clear, nothing is difficult for you. If your concept is clear, nothing is difficult for you in physics. So let's solve. So the question is, point masses M1 and M2 are placed at the opposite ends of a rigid body of length L. Okay, so this is the rigid body, something, let's say rod is there, whatever, and two point masses are attached at the ends M1 and M2, okay, and the rigid body of length L is negligible in mass, negligible. So we are not considering here the mass of this rigid body. We have to consider only the mass of M1 and M2 which is connected. Thala Mahmood Hasar, wow, superb. Okay, focus here. The rod is said to rotating about its axis, means the rod is rotating around this axis. This is the axis. This is axis of rotation. Along this axis, this whole body is rotating in this way, and we have to find out the position of point P on this rod through which the axis should pass, so that work required to set the rod rotating with angular velocity V0 is minimum. This is very important, my dear champion. We have to find out here the position of P. The position of P means X. We have to find out X here, so that the work will be minimum. The work will be minimum. This is the question, my dear champion. And do you know, when something will be rotating, so work done will be due to kinetic energy. If this whole combination, this whole body is rotating, so the kinetic energy will be there. So we have to write here the kinetic energy. Are you getting my point? So do you know the kinetic energy is having formula? If we talk about kinetic energy, so kinetic energy, this will be in the form of work done, and which will be 1 by 2 I, and omega naught is the angular velocity, so omega naught whole square. I omega naught whole square. I is what? I is what? I is the moment of inertia of whole system. So we have to find out here moment of inertia of whole the system. Moment of inertia due to this at here, according to this is our axis of rotation. Axis of rotation. This is our axis of rotation. So we have to find out first complete moment of inertia. So what will be the complete moment of inertia? Do you know, my dear, complete moment of inertia? The moment of inertia will be here due to this M1, and we are finding moment of inertia along this axis. So M1 x square, because x is the distance at this axis for this mass, plus if we consider this mass, the distance will be L minus x. So we can write here M2 L minus x whole square. This will be the complete moment of inertia. I hope you all are getting my point. This is the complete moment of inertia along this axis of rotation, right? So now we can put here W will be equal to half, and complete moment of inertia is equal to what, my dear champion? M1 x whole square plus M2 L minus x whole square and omega naught whole square. This is the work done. Now the question is that what should be the position of P so that the work done, so that the angular, so that the work required to set the rod rotating is minimum. If this work done is in the form of X, and we want work done is minimum, work done is minimum. What should be the position of X, position of P, so that work done is minimum? It means that we have to differentiate this with respect to X, and we can put equals to 0. We all know to find any function, to find any value, any function, minimum value for any function, we always differentiate that function with respect to, if this is t, so we can differentiate with respect to t, but this function of work done is with respect to x in the form of x. So we have to differentiate with respect to x, and we want work done minimum, so the differentiation of work done with respect to x will be 0. So just differentiate it. So if we differentiate this whole function, so d by dx, and this is half, and what is this, champion? M1 x square plus M2 into L minus x whole square, and this is omega naught whole square, and we have to differentiate it. So can you find out, my dear champion? 1 by 2 is what? 1 by 2 is constant, so that will directly come out. 1 by 2 will come out, and if we differentiate M1 x square, so this will become 2x M1. The differentiation of x square with respect to x will be, the differentiation of x square with respect to x will be 2x. Now, plus, can you see here, this is M2. And the differentiation of whole bracket, because this is L minus x, so the differentiation of whole bracket will be 2 into L minus x, and the differentiation of minus x will also go. So the differentiation of minus x will be minus 1, and this is whole omega naught square will be equal to 0. Done. 1 by 2 is constant, which is in multiply form. Omega naught square is multiply form, so that will go at the right side and the whole function will become 0. So what we are getting here, we are getting, okay, but we can take common as well. We can take 2 common. So 2 will common, 2 will cancel here, and this 2 will cancel here. So we are getting here m1 x, and minus 1 will multiply here. So minus, and this is here m2 into L minus x will be equal to 0. So can we solve this? M1 x will be equal to, this whole family will go there. So m2 into L minus x champion. So x will be equal to m2 into L minus x divided by, this is here, this is m1. So any option is there? Can we find any option? So m2 option number, okay, so we want x here now, so this x is also disturbing here, so we can take x family at one side to get the value exactly same. So just solve this. We cannot take direct value because x is also present at the right side. So let's do one thing, open the bracket. So m1x is equal to m2l minus m2x, right? This m2x will go there, so x will be m1 plus m2 is equal to m2l. So x will be equal to m2l divided by m1 plus m2, m1 plus m2. I hope now this is clear to you all. Any option is there? m2l, very good. m2l divided by m1 plus m2. Option number B will be the correct answer. This is the beauty of question. So the most important part in the solution of this question is to find out the total inertia. The total, this is I net, the total inertia of the system. Yes, clear? Yes, Shruti, if tomorrow is your KCET exam, I think, yeah. So these questions are very helpful for you. Yes, very good. Yeah, bio is there for few degrees, for few course, bio is also there in KCET. For few course, not MBBS and not the such courses. Okay, Shiva is correct. Option number B, Shiva, you are correct here. Is it clear to all? See, the question was, we have to find out here minimum work done. Look, the position of P, what should be the position of P on this rod through which the axis should pass, so that the work required will be minimum. And if we want work done minimum, so we have to write dw by dx is equal to 0. And by differentiating the work, the function of work with respect to x, we can get the value of x. No. If you are PCMC student, you cannot. Maleshwari. If you are having background of biology, if you are having biology as well, then only you can appear for biology in KCET. Otherwise, you cannot. Okay. Is it clear to all champions? Very important question from Neet 2016, my dear champion. Yes. Manya, option number B is correct. Very good, Manya. Option number B is absolutely correct. Moving to next question. Okay, wow. One of the good question. So look at the question, champion. This is from the previous year. From the question paper of 2025. Just previous year. 2025 from Neet. A uniform rod of mass 20 kilogram and length 5 meter leans against a smooth vertical wall, making an angle of 60 degree with it. The other end rests on a rough horizontal floor. The friction force that the floor exerts on the rod. So see, in this question, nothing is challenging. But the important part is draw the situation. If you are able to draw the situation for this question, the rest part is very easy. You need to visualize the situation, you need to write the equation, and you need to do the mathematical calculation. Otherwise, nothing in the question. Read the question calmly and draw the situation. Let's do. Okay, so the question is a uniform rod. So there is a wall, vertical wall. So my dear champion, let me solve from here. Okay, I'm using this space. So this is wall. let's say this is wall, okay, and this is wall here. Let me use shaded portion for the wall. Okay, this is wall, and a uniform rod of mass, uniform rows. Uniform rod means mass distribution is equal at everywhere. Mass distribution is equal at everywhere. It means that the center of mass will be exactly center. The center of mass will be exactly center because uniform distribution of mass is there. Okay, now a rod of length 5 meter is leans against the wall. So let's say this is rod, this is ground, and this rod is leaning against this wall of 5 meter. The length of the wall rod is 5 meter basically. So let's take it as L, and this is the rod of length L, and basically this L is equal to 5 meter. Okay, write this, and mass is 20 kilogram. So at the center here, this will be the mg. I'm putting here mass, that is weight from exactly the center. Why? Because the rod is having uniform mass distribution, so the center of mass will be exactly center, and if the center of mass is exactly center, the weight will be from the center towards the downward direction. So this is the weight. Okay, now can you see, my dear champion, if this rod is leaning against this wall, so this rod tends to go in backward direction. The bottom of the rod tends to go in backward direction. If it might slip, if it may slip, so the rod will go in backward direction. The motion of rod will be in backward direction, and this is friction. Here is friction. This is rough surface, so the friction force will be in this direction. This will be the friction force. This is the very important thing to observe. This will be the friction force, and this rod having contact with ground, so here in this direction there will be a normal force, and here the rod is in contact with this wall, so here there will be normal force. Let's say this is N1 and this is N2 here. I hope this is clear to you all. So the diagram, observation and showing all the forces acting, this is very important thing. So my dear champion, now the question is, we have to find out here the friction force that the floor exerts on the floor. Now very important thing, can you see here my dear champion, friction force is here in this direction, and this normal is in that direction. Friction is in this direction, and the normal N1 is that direction. So we can write here N1 is equal to friction. This is the first condition. Now can you see, N2 force is in upward direction and weight is in the downward direction. N2 is in upward direction and weight is in the downward direction. So we can write here N2 will be equal to mg, which is weight. I hope this is clear to you all. Now the very important thing, listen, just look at the diagram. Can you see here, my dear champion, if this rod slips, I mean this rod, the top of the rod will slide down, and the bottom of the rod will slide in this direction. So there will be torque. Due to torque, the rod will tends to rotate, and torque is acting by two forces. Can you see here, my dear champion? If you can see here, this is the N2. This is the N2, and for N2, this will be the perpendicular distance, because the rod is rotate about to this axis. The rod is rotate to about this axis. So this will be the perpendicular distance. Can you see? Let me show by red color. This and this, right? N2, and this will be the perpendicular. Now if we talk about N1, for N1 let me use green color. So this is N1, and this will be the perpendicular distance for N1. So you all know the formula for torque. You all know the formula for torque. Torque is equal to I alpha, or torque is also equal to force into perpendicular distance. I hope you all know this formula. Force into perpendicular distance. Just we need to apply the same formula here. So just solve it mathematically and let me know the answer. Everyone, I have solved half part of this question. I am looking at the chat section. Tata Aisha, hi Aisha. Yes, Shiva is writing option D. Okay, wait Shiva, just a little while. Wait Shiva, champion, wait. I want to see answer from you guys. Everyone, try it. Come on. What would be the answer? Come on, try everyone. Everyone, I want answer from you guys, everyone. Very easy question. KA, DF, DE. Oh. KA is also writing D. See, my dear champion, listen. The torque acting by this N1 and the torque acting by N2, or we can say mg also, because N2 and mg both are same. Both will be same. So we can directly solve this. Listen. Torque, the formula for torque is equal to perpendicular distance into force. Right? So torque acting due to this, so we can write N1 into this will be the perpendicular distance. Can you see here? And my dear champion, 60 degree is the angle which is making here. This is the 60 degree. Right? So what will be this? And this whole complete is L. So if you write here sine theta is equal to perpendicular by hypotenuse. So sine 60 is equal to perpendicular by hypotenuse is L. So P will be equal to L sine 60. L sine 60 complete. So this will be equal to L sine 60. Now come to mg, the torque acting due to this, and torque acting due to this, and torque acting due to this, and the perpendicular distance will be this. For weight, the perpendicular distance will be this. So can you see here, this is L by 2. And if this is L by 2, we require this, not perpendicular, we require base. So base will be equal to L by 2 cos 60. So can we write here mg into L by 2 cos 60. This is all about. So now this N1 is equal to friction, so we can replace this as a friction into L, and sine 60 is equal to root 3 by 2 mg. M is what? 20 kilogram. 20 into G is what, my dear champion? G is, of course, G. What we have to take here? G is 10, and L by 2, keep it as it is, and cos 60 is 1 by 2. So we have put it all the values. So L will be cancelled here, right? And this 2 will be cancelled by this 2, and this will be cancelled by this. So this is 100 root 3. So friction will be equal to 10 into 10, 100, and this is 100, and this is root 3. Root 3 is in multiplication form, so root 3 will go there. So 100 by root 3 answer. Friction force is equal to 100 by root 3. Can we solve this? If we do multiplication, so this is mg L by 2 cos 60 is 1 by 2, sine 60 root 3 by 2, and mg perfect. This is perfect. So N1 is equal to friction force, and N2 is mg. So 100. Yeah, any option is there? 100 by root 3 we are getting here, and this is mg 20 into g. 20 into g, 2 will cancel, 1 2 is cancelled here, and 1 more 2 will cancel this. So 100 by root 3. Yes, what you are getting, guys? What is your answer, everyone? Tell me. What is your answer? Yes, everyone. Which option will be correct? Yes, Ananya 89. You guys are talking with each other. mg L by 2. Yes, tell me. So basically here the question is, listen, the most important part. Look, making this 20 kilogram and length 5 meter leans against a smooth vertical wall making 60 degree. This is very important, and we have shown this 60 degree here with ground. No, this angle is basically the uniform road is making with the wall. So this is very important point. This is very important point. This 60 degree will not come here. This 60 degree is basically here, champion. The reading the question carefully is very important. So this will be 30 degree, and if this is 30 degree, the everything will be changed. This will be 30 degree, here will be 30 degree, and here will be 30 degree, and that is the reason why we are getting here the different answer root 3 in division form. Now you can solve here. So this will be n1 sine 30 is there, and this is cos 30 is there. Now we have values. L will be cancelled here. So n1 is basically friction. So friction is equal to sine 30 is equal to 1 by 2, m is equal to 20, g is equal to 10, and this is 1 by 2 here, and cos 30 is equal to root 3 by 2. Now you can get the values. So 2 will cancel here, and 2 will cancel this by 5. So friction is equal to 100 root 3. Of course, Newton will be there. So option number D will be correct. So reading the questions carefully is very important part, because the question is saying the rod is leaning against the wall at 60 degrees. So if this is 60 degree, this angle will become 30 degree. And if this is 30 degree, the value of this hole will be equal to L sine 30, which is perpendicular distance for N1, and L cos 30 degree, this will be the perpendicular distance for L2. So I can write here L sine 30 degree is what? Perpendicular distance of force N1, right? And L by 2 cos 30 degree is what, my dear champion? Perpendicular distance of force, what? Mg. For mg, this is mg here, this is mg here, this is mg here. So for mg, the perpendicular distance will be L by 2 cos 30. Yes, is it clear to all? Shiva, is it clear everyone? Any problem to anyone? Please let me know. This is very important question, and this question is from PYQ 2025 Neet. 2025 Neet. The right answer will give you 4 marks plus 4 marks, and the wrong answer will give you negative marking. Wrong answer will give you deduction of 1 marks, and the right answer will give you plus 4 marks. So you have to be very clever while filling the bubble, while choosing the correct option there. Okay, moving to question number 3. Okay, look at the question number 3, champions. Yes, Shiva, try. Everyone, try this question. Hi, Ananya, Pradeep. Try this question, everyone. Yes, which option will be correct, guys? Pradeep Godachi. Pradeep, any problem to you? Ananya, Uma, any problem to you? I can repeat the question again for you, Pradeep. Let me know if you are having any problem. Any problem to anyone? Did you understand the solution, guys? So torque acting due to this force will be equal to torque acting this force, because the rod is leaning. So this torque and this torque will be balancing each other. This is equilibrium question basically. Basically this question is from equilibrium. Equilibrium question. Equilibrium concept. Right. This is equilibrium constant. I hope you have studied about equilibrium. R1 F1 is equal to R2 cross F2. Same formula we have applied. R1 here is what? R1 here is L sin theta, F1 is N1, and R2 here is L by 2 cos theta, and F2 is mg. Yes. C. Okay. Lot of student is writing option number C for this question. Okay. SK Gaming, KA, I don't know your name, KA. Tarun is there, I think. Shiva, Pradeep is saying question number C, option number C. Okay. Look at the question. What is this? A solid sphere. Okay. Solid sphere is in rolling motion. Perfect. Rolling means there will be translational motion and rotational motion both. C is correct answer. Okay, Pradeep, just wait a little while. Okay, so there is a solid sphere. Now, if you saw here, solid sphere is there. It means that it is clear that the moment of inertia of solid sphere will be equal to 2 by 5 mr square. I hope you all know this formula. 2 by 5 mr square for the moment of inertia of solid sphere. Okay. Now, is it in rolling motion? In rolling motion, a body possesses translational kinetic energy KT as well as rotational kinetic energy. Of course, if something is rolling, so there will be both motion, translational as well as rotational. So energy will be both rotational kinetic energy and translational kinetic energy. Okay, so we have to find out ratio. Okay, so my dear champion, what will be the kinetic energy rotational translation? That will be equal to 1 by 2 half mv square. This is the first, if solid sphere is rolling there. And what will be the rotational kinetic energy? So Kr, rotational kinetic energy, will be equal to 1 by 2 half omega square. I hope you know this formula. This is the formula for rotational kinetic energy for any solid body, right? So you have to write here moment of inertia, and we are talking about solid sphere, so the moment of inertia is 2 by 5 mr square. So kinetic energy rotational will be equal to 1 by 2 and I will be equal to 2 by 5 mr square, and v omega can also written as v square divided by r square. Do you know how? Because v is equal to r omega. This is the relationship between translational angular velocity and rotational velocity, and linear velocity, which is called translation as well. V is equal to r omega. So my dear champion, omega can also be written as v by r. Is it clear to you all? You have to keep every formula in mind if you are writing your NEET exam. You cannot ignore any small formula. Even a small formula will be playing a crucial role there. So omega can be written as v by r. So omega square will be v square by r square. So this r square cancel here, this 2 cancel here. So rotational kinetic energy will be equal to 1 by 5, and this is m here and this is v here. So mv square, this is second. So can we go through? We need to KT plus KR, so just add here as it is. So KT, technical problem, KT plus KR will be equal to half mv square plus 1 by 5 mv square. So if we take LCM here, so let's mv square common, so this will be 1 by 2 plus 1 by 5, right champion? So this will be equal to mv square. Can we take LCM here? So the LCM of 5 and 10 will be here 10, right? So 2 5 are 10, so this will be here 5 and 5 2 are 10, this will be, so this we are getting here 7 by 10 mv square, right? Now we required KT by ratio, so KT by KT plus KR will be what? KT is translational kinetic energy, which is half mv square, divided by, this is sum of total energy that we required, KT plus KR, which is equal to 7 by 10 mv square cancel, so 10 will go there, and this is 2 into 7, so 2 5s are 10, so we are getting here 5 by 7, which is equal to 5/7. Answer option number B. And can you see, my dear champion, this question has appeared twice, in the year 2018 and very long ago in the year 1991. So I looked this question as an important question, that's why I brought up this question here, but very easy question because just formula is required. So my dear champion, please keep these two things in mind. This is translational kinetic energy and this is rotational kinetic energy. 1 by 2 half I omega square. I hope this is clear, everyone. Yes, champion, this Karthik, yes, of course. See, my dear champion, if you are NEET aspirants and if you are going to write your NEET exam on 3rd of May, my champion, listen, in NEET, the questions, the patterns repeats. The question will not exactly same, but the pattern repeats every year. And just look at the repetition here. So the question that I thought like these questions are very important for you guys. So I have brought up these questions. And yes, most probably, there will be question based on these things in your coming exam. Not exactly same. I'm not saying this, the exactly same question will come there. But the overall, at some extent, the 90-80% pattern will be exactly same. So this is the beauty of this session. Okay, Karthik, is it clear? I hope you got the answer. Is it clear, everyone? Yes, yes. Shiva, correct. Story channel. Yeah, you are correct. Option number B is correct here. And yes, everyone. Who is this? Okay. Yes. Okay. Perfect. Answer B. Yes, Karthik. Answer B is correct. I hope. Yes, Rangapat, yes, C is not correct answer. 5:7 will be correct answer. Because in this question, we have to find out the ratio of translational kinetic energy to the sum of translational and rotational. So this is translational kinetic energy, just normal, simple, half mv square, and this is rotational kinetic energy, half I omega square. And we have written here the omega, moment of inertia for solid sphere, because we are talking about solid sphere, and we have replaced omega by v square by r square, because omega is equal to v by r. Omega is equal to v by r. So by replacing omega from v square by a square, solving mathematical calculation is there, we got the sum of translational and rotational kinetic energy is 7/10 mv square, right? And by putting the value, we got the answer. Yes. Very good. Should I move ahead? Moving to the next question, and look at the frequency. This question has appeared twice, in 2018 and 1991 in NEET exam. In NEET. Okay, so very important question. Moving to next. Okay, question number 4. From a circular, okay, so there is a circle. From a circular circle, so this is not solid, this is not disc, just normal circle. Means we are talking about ring. If this is normal, circular, we are not talking about any specific shape, cylinder, sphere or disc, whatever, only circular. So it means this is a ring, like wheel, like bangle. So from a circular of mass m and radius capital R, an arc corresponding to a 90 degree, it means one quadrant, sector is removed. So from a circle, one quadrant is removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring, and they have mentioned here ring. They have mentioned, as per my assumption, this is correct. So I also told you ring, so ring is coming here. So here in this question we are talking about ring. Okay, and perpendicular to the plane of the ring is k times mr square. Then the value of k will be what? Wow, easy question. Thanks, sir. Okay, thank you, Rangab. So look at the question. So basically the question is, champion, listen, I'm giving you solution. So let's solve the question. So basically there is a ring. This is a ring of radius r, and having mass capital M. This is the ring, right? From this ring, an arc corresponding to a 90 degree, it means that 90 degree, do you know this will be the 90 degree? This will be the 90 degree. So this arc has removed, this arc. Can you see here? This is the bold arc. This arc is removed. And after removing this arc, this is removed. After removing this arc, I think this ring will look like this. This ring will look like this. This ring will look like this. And we have to find out the moment of inertia of this. And do you know, my dear champion, when some part from solid or from any structure is removed, so the moment of inertia of remaining solid, this is the remaining part. This is the remaining part. And do you know, the moment of inertia of remaining part, I remaining will be equal to I original before removal, I original minus I of removed part. This is the formula. Please keep it in mind always. If you want to calculate the moment of inertia of remaining solid, so the moment of inertia of remaining solid, remaining part, remaining shape will be equal to IO, it means original moment of inertia, minus moment of inertia of this part, which has removed. Let's say, let me draw here. So this is the removed part. This is the removed part. So what will be the original moment of inertia, champion? The original moment of inertia is just ring, and the axis of rotation is here. This is passing through. Axis of rotation is from center, which is perpendicular to the plane. So I naught will be equal to mr square. This will be I naught, IO, original. And what will be the moment of inertia of this part? So the moment of inertia of removed part, I removed will be equal to what, champion? If we are removed here, we have removed here 1/4. 90 degree means what? 1/4. So what will be mass? Mass will be 1/4, m by 4. R square. Similarly, radius is still r, and this is r, so radius will be this. So this will be the I removed m by 4 r square. So answer will be equal to here. So can we find out here? So I will be equal to mr square minus m by 4 r square. So what will be the result? Can we take LCM here? So 4 mr square minus mr square will be 3 by 4 mr square. So this is the answer. 3 by 4 mr square is the answer. 3 by 4 mr square is the answer. But this is not answer. The question is, this moment of inertia is equal to k times mr square. So can we write here k into mr square will be equal to this 3 by 4 mr square. 3 by 4 mr square. So mr square cancelled here. So k will be equal to 3 by 4. This is the answer. Any option? Option number B will be correct. Is it clear to all, champions? Please tell me. Honestly, you all are enjoying the session. Please tell me. So moment of inertia of remaining part is equal to moment of inertia of original part minus moment of inertia of removed part. Keep this formula in mind always. Yes, is it clear to all? Sinchan, is it clear to all? Yes, tell me. I'm looking at chat section. Sir, option B is correct. Yes, option B is correct. Perfect. Pradeep. Very good, Shiva. And the student who haven't pressed the like button yet, go and hit the like button, champions. Everyone, KA, Pradeep. Very good. So if you practices these questions honestly with me, my dear champion, genuinely, and this is my assurance to you, you can improve your marks in NEET plus 45. Please consider plus 45 is increasing. Damn sure. If you practices these questions with me, plus 45 confirm. So stay in this live class till the end. Your physics concept in rotational motion will be cleared. Everything will be cleared here. So plus 45 marks is confirmed if you watch my live sessions, all the live session till 2nd of May. Okay, thank you so much, Sinchen. Panduranga, thank you so much. Who is this? Sikandar. Hi, Sikandar. So if you guys are enjoying the session, show me your involvement, send me some hearts, send me thumbs up. You all are enjoying the session. And hit the like button also. Hi Pradeep. Thank you, Pradeep Godachi. Thank you so much, everyone. Should we move ahead to the next question? I hope the concept is clear to you all. Moving to the next question. Wow. This question is from the year 2013. 2013 NEET, but I consider this question as a quality question. That is the reason why I have brought this question in front of you. Okay, a rod PQ of mass M and length L is hinged. Hinged means fixed. Let's say some rod is there, and this rod is welded with this rod. So this is hinged, not hanging. This is hinged. So the rod is straight. The rod is kept horizontal by a massless string, which is hinged. Massless string, okay, tied to point Q, okay, as shown in figure. When this string is cut, the initial angular acceleration of rod will be what? Oh, wow. So we have to find out initial acceleration. Do you know initial acceleration? And which acceleration we are talking about? Angular acceleration. So angular acceleration, we have to find out here alpha. Angular acceleration means we have to find out here alpha. And once you got, like, you have to calculate alpha here. So now think about the formula, all the formulas in which alpha comes up. Think about all those formulas in which alpha comes up. where alpha comes up. There are so many formulas where alpha comes up. So think about all those things where alpha comes up, and you can get the result. Solved it, sir. Pradeep is saying solved it, sir. Very good, yaar. Superb. Yes, which option will be correct? See, Prem, thank you, Prema, for giving this thumbs up to me. Thank you, everyone. Okay, try it once, please, everyone. I'm looking at the chat section. Who will give me the answer of this question? Pradeep, which option you got? Okay, do it fast. Come on, everyone. Very important question, very important. Sir, I think one option. No, I think is not valid. I think no guessing is valid. Give me your correct answer confidently. Yes, sir, this is my answer. Lock it. Yes, Shiva. C is correct, sir. Okay. Sir, C. Okay. Majority is writing option number C. So let's solve. So, my dear champion, did you understand the question? Here in this question, we have to find out angular acceleration. So think about angular acceleration. How many formulas are there in which angular acceleration comes up? In which angular acceleration comes up? This is the logic. Pandurang, Pradeep, yes sir, option number 1. Okay. Okay. Shanta, Chandru, option number B. Someone is writing option A, someone writing option B, some student is giving option C. So majority is writing option C. Let's solve the question. Okay, so look at the screen. Champion, just for a while, please focus on the screen. Okay, so don't rush, don't go in hurry, like don't feel panic after reading the question. Just stay calm, read the question carefully and draw the situation. Yes, you can apply strategy, but your guessing should be very smart. Ananda is saying, yeah, guessing is there. When every door is closed, there is no way. Now you have stuck in the solution. You are not getting the correct answer. Now every door is closed. Now there is one option, smart guessing, not random guessing. Because random guessing will lead you negative marking. Smart guessing, you can follow the elimination procedure, eliminating the options. So you can move through options as well. Okay, so let's solve the question. Okay, so when this string is cut, so this string is cutted down. So this string is cutted down. After cutting the string, this will go this way and this portion will go down. Right, my dear champion? This portion will go down, so there will be angular speed, angular acceleration as well. And if this rod is, can you see, a rod of mass m and length L is hinged, the rod is kept horizontal by a massless string, this, and the center of mass will be somewhere here, and this mg will here. If rod will go down, so rod will tends to rotate in this format. So axis of rotation may be passing through somewhere. So rod will go this way. This portion will go down first. So do you know, my dear champion, we have the formula for torque. We have two formulas for torque. Torque is equal to, if you remember, I alpha. The first formula for torque is I alpha. And if you remember, for torque, there is one more formula, R cross F. There is one more formula, R cross F. If you remember this formula, so this question is nothing for you. So if this is torque, apply. So I alpha will be equal to RF, and this is F here, and this is R. So R will be L by 2 for mg. right? And the angle is here 90 degree, so we can write here sine 90. So basically sine 90 is of course equal to 1, so we can ignore also. Okay, now we are talking about here, this is rod, this complete is rod. So do you know the moment of inertia of rod? So moment of inertia of rod is what, my dear champion? If you know, tell me. Who is this? C option is correct, sir. Yes, 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 champion. C is correct. Just wait a little while. So what is the moment of inertia of rod? Rod is hinged from this position. Rod is not moving from center. If rod moves from center like this way, so the moment of inertia is ml square by 12. And if the rod is fixed from one point here, this point, and rod is about to move in this way, so the moment of inertia is ml square by 3. So for this situation, the moment of inertia, because the rod is hinged from one end, so the moment of inertia will be equal to ml square by 3. So can we write here, this is m, this is ml square by 3 into alpha, which we want to calculate angular acceleration, and r is equal to L by 2, and f is what, mg, and sine 90 is obviously 1. So we can find out here the value, m will be cancelled by this m, 1L will be cancelled by 1L, so we can get the value alpha will be equal to 3 and g divided by this L will come here, so 2L. So this is the alpha, 2g by 3L as 3g by 2L. Option number C will be correct. Who responded me option number C? Let me check. C is correct, sir. Very good. K is correct, Prema is correct, Suhana is correct, Shanta, Chandru, B. Shanta, I think you made some mistake. Just solve this question again. Option number C will be correct, 3g by 2L. Do you know why? Because I have applied, see, in this question, we have to find angular acceleration. Now think about in which formula angular acceleration comes up. So the angular acceleration comes in this formula, torque is equal to I alpha, and we have one more formula for torque, which is equal to RF. In vector form, in a scalar form, RF sine theta. And F is what? Which force is acting on this rod? Only weight is there, champion. The weight is acting. The weight will bring this rod in downward direction. Weight is the force. So for weight, the perpendicular distance will be L by 2. Weight is producing the torque here. So perpendicular distance L by 2 and force is weight, mg, sine 90 is 1. So after putting the value, we got alpha. I hope this is clear to you all. Any problem to anyone, please let me know. If you are having any problem, please let me know, champion. So torque, we have two formula for torque. Torque is equal to I alpha, the first formula, right? And the torque is equal to R cross F. Please keep these two formula in mind always. This formula, very important. Torque is equal to I alpha, first formula, and torque is equal to R cross F. So sometime in some question, you require to find out the angular acceleration. So you need to equate both the equation. Once you equate both the equation, you can find out the angular acceleration that you required angular acceleration. Yes, any problem to anyone? Tell me honestly. Any problem? Anyone confused? Is there anyone who is still confused? Who is still having any problem? Please let me know. I can repeat the solution again for you. Please tell me. Any problem to anyone? Suhana, yes, C is correct. Suhana, perfect. Any problem to anyone? Should I move ahead to the next question, champions? Should I move ahead to the next question? Okay. No, sir. Very good. Very good. Okay. So, very good. Very good, Shiva. Next question. Are you ready? Are you ready to face the next question? And I know in physics, if I talk about physics of class 11th and 12th, PUC first year and second year, class 11 physics is little bit scary, little bit difficult comparatively to PUC second year physics, and especially this chapter. Because in this chapter, you required your imagination power. You required visualization. You required strong imagination. I know this chapter is little bit different and difficult from other chapter. Okay. Are you ready for the next question, champions? Okay, moving to next question. Oh my God, this question is from the year 2024 Neet. Okay, very easy question, very easy question. So read the question carefully. Okay, so there is a wheel. This is a wheel. So a wheel of bullock cart, is rolling. Come on, rolling. What is there? This is pure rolling. Rolling. What is there? Very important term. Rolling on a level road, as shown in the figure. Okay. If its linear velocity is v in the direction shown, so this wheel is having linear velocity. Here is v is not visible, so let's draw it again. So this is the linear velocity. Which one of the following option is correct? P and Q are the highest and lowest points on the wheel respectively. So if the wheel is rolling, this is perfectly rolling, pure rolling, champion. So the center of wheel will also having same velocity v. And do you know, champion, when some wheel rolls, so here at the highest point, the rolling velocity, means the translational velocity is of course v, same velocity, we have given the velocity, and the rotational velocity due to rolling will also in the same direction. This is the rotational velocity Vr, and this is the translational velocity, and the important thing is both will remain equal. At the highest point, both is equal. Okay, as you move to this point, here at this point, the particle tends to go in this direction, and here at the bottom point, the particle will go in this direction. So at highest point, the translational velocity, linear velocity, and angular velocity, which is rotational velocity, both are in same direction. But at the lowest point, the linear velocity will go in this direction, and the translational velocity, which is translational velocity, can go in forward direction, and the angular velocity due to rolling will go in backward direction. This is angular velocity, which is rolling, and this is translational velocity. So can you see, my dear champion, at the highest point, velocity at point P will be equal to Vr plus Vt, right, my champion? And both are equal, so V is equal to R omega, so Vp can be right here, Vp R omega plus R omega, so Vp will be equal to 2R omega. This is the velocity at the highest point. Now if we talk about here at VQ, this is the first part, so this is equal to Vt minus Vr, and both are equal in magnitude, so omega R minus omega R, which is equal to 0. So the velocity at Q point of the particle of this wheel will be 0. They looks like at the rest. If this is rolling completely, this is pure rolling. So if the wheel is rolling as well as moving in forward direction, so the bottom point will look like the particles at the bottom is at rest position, and this particle at the point P will be moving very fastly. So if the center is having velocity v, so at this position the velocity will be 2v. Keep it in mind always. So at which point the velocity will be highest? So point P moves slower than no. The point P moves faster than point Q. Yes, this is correct. Third point, both the points P and Q move with no equal speed. Point P has 0, none at all. So this is the answer number B. I hope this is clear to you all. Please keep it in mind. So velocity at the highest point is twice of R omega, and the velocity at lowest point is equal to 0. Keep it in mind always. So which point will be moving faster? The point at P. Sir, option B is correct. Option B, Pandura, is option B is correct. Very good. B is correct. Superb, everyone. Very good. Shiva, correct. So I have given you proof also. Okay, champion. This Vt is translational, which is also called linear. Okay, enjoying the session? Feeling confident? Tell me. Feeling confident? Tell me honestly. Feeling confident, champions? You all are enjoying the session? Tell me honestly. Yes sir, we are enjoying the session. Tell me. And go and press the like button also simultaneously. Yes, let's move to the next question number 7. Okay. Yes sir, thank you so much. So look at the question. A disc of radius 2 meter. Oh my god, this is a disc. If this is disc, so the moment of inertia will be mr square by 2. Okay. keep it in your mind, of radius 2 meter and mass 100 kilogram, rolls, oh, again we are talking about rolls on a horizontal surface. Its center of mass had speed of 20 centimeter per second. 20 centimeter per second. So we have to convert into meter per second, because centimeter is not SI unit. How much work is needed to stop it? So we have to find out here work done to stop the disk here. Very easy. So kinetic energy, if something is rolling, so the work done will be kinetic energy. Yes. Yes, sir. Pradeep, thank you. Suhana, thank you so much, everyone. So solve this question. I'm giving you 1 minute for this question. Everyone, I want from you all the correct options, correct answer of this question. Very easy question. We have to find out work done. Yes, work done. Work done means kinetic energy. Solve it. Come on. Sir, option B is correct. Okay, Shiva. Okay, Shiva. Wait a little while, Shiva. Let others do this question. Very easy question. This is directly formula based, champion. Tell me which option will be correct here. Suhana, sir, B option is correct. Okay, Suhana, just wait a little while. 1 minute only. How much work is needed? And this is from the year 2019. Can you see? 2019. Very important question. Just formula based only. B is correct. Okay. Lot of student is writing B option. Try everyone. Please try everyone. At least once. Try everyone. Okay. Majority is saying which option? Option number B. Shiva, Pradeep. Okay. Listen. So, a disk is rolling. My dear champion, if something is rolling, so there will be both things. Translational motion as well as rotational motion. Are you getting my point? Translational motion as well as rotational motion. So, I can write here translational motion plus rotational motion. And if both is going on, so there will be kinetic energy for both due to both the phenomena. So how much work is needed to stop it? So the energy that this wheel is having, we required as much energy from external to oppose that, right? So we have to find out here the total work done. So total work is what, my dear champion? Total energy. Total work means total energy, and total energy means what? Kinetic energy rotational. So kinetic energy rotational plus kinetic energy translational. Simple. And you all know kinetic energy rotational will be equal to half I omega square, and kinetic energy translation will be equal to half mv square. Is it clear? Now we are talking about disk here. So for disk, moment of inertia will be equal to mr square by 2. I hope you know this, mr square by 2. Now we can put the value there. So half m r square by 2, and this is omega, and I've already given you the formula. Omega is equal to V by R, so omega square will be equal to V square by R square. We can put there. So this will become V square by R square plus half mv square. Keep as it is. Now R square will cancel, and this is 2 to the 4, and by taking the LCM, so this is 1 by 4 mr square, and this is 1 by 2, and this is r cancel, sorry, mv square, this is not r has cancelled, so v square, this is 1 by 4 mv square, and this is also 1 by 2 mv square. Can we take common? Mv square and 1 by 4 plus 1 by 2, that will be equal to what, my dear champion? On taking LCM, 4 will be LCM 2 to the 4, so this will be 3 by 4. 3 by 4 mv square. Now put the values. 3 by 4, where is the mass? Where is the mass? Where is the mass? Mass is equal to 100. So this is 100. And where is V? V, 20 centimeter. So 20 into 10 to power minus 2. And this is whole square. So whole square will come there. centimeter, 20 centimeter. So 20 centimeter will be 20 into 10 to power meter per second, 10 to power minus 2 meter per second. So solve it. So 25 will cancel this, and 25 3 is 75, and this is 20. 20 square will be 400, and 10 to power minus 2. 10 to power minus 2 will be equal to 10 to power minus 4, right? And we required energy here. So 75 into 400 divided by 10 to power 4. 1, 2, 3, 4. Can we cancel this? 0, 0, 0, 0, and this 4 will cancel. This 4 will cancel this 25, and 25 will cancel this 3. So we are having 3 joule energy. Where is 3 joule? Option number B will be correct. I hope this is clear to you all, champions. Any problem to anyone? Sir, B is correct. Yes, B is correct. You all are correct. Hi Kirti, hi Suhana. Yes, B is correct, champions. B is absolutely correct. If possible, you guys can take a screenshot. You guys can write the solution using your pen and notebook. And if you want to click the photo, come on, click the photo as well. Yes. I'm looking at the chat section, everyone. Yes. Correct. Correct, everyone. Any problem to anyone? Please let me know. A lot of students are watching the session here. Yes, sir. Correct, sir. B is correct. Very good. B is correct. Superb. B, 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 B. Okay. Go and hit the press the like button, everyone. Don't forget to press the like button. Go and hit the like button first. Clear, everyone? So very important thing. This is moment of inertia, and please, this is omega. Omega is equal to V by R. Kirti, yes. Moving to next question, question number 8 from Neet 2016. And let me tell you, in Neet, same patterns repeats. Yeah, the question will not be exactly same, but the patterns mostly repeats. The question will be little bit similar. So that is the reason why you should practice PYQ. Don't read theoretical part now. Don't try to revise entire theory, entire syllabus. You cannot do. This is not the right time, champions. So you should focus only on PYQs. And this session will play a very important role to enhance your performance, to increase your rank and score in your exam. So this is my humble request to you. If you have joined the session, stay in the session till the end. Because you just need to look at the screen. If you are not able to get the answer correctly, if you don't know the formula, if you don't have approach, I know this chapter is little bit tough. This is system of particles and rotational motion. So I know this chapter is little bit different from other chapter because it required imagination, visualization, formula, mathematical calculation. Lot of things are there. Sir, I hit the like. My mobile screen broke. Give me money. Sure. So yeah, I'll be gifting you a new mobile phone if you come under 100 rank in your NEET exam. If you get good rank in your NEET, I'll be gifting you a mobile phone from my end. Good mobile phone, not a cheaper mobile phone. Good mobile phone, expensive one. Yes, sir. Option B is correct. How do, sir? Is it? Did you understand my words? What I told you guys, everyone? Very important thing. Trust me. Sir, option B is correct. Hi, Chiru. Okay. What is the question? A solid sphere of mass m and radius r is rotating about its diameter. Okay, about its diameter. A solid cylinder of the same mass and same radius is also rotating about its geometrical axis. Geometrical axis means center, with an angular speed twice that of the speed of sphere. Okay. So the angular speed of cylinder here in this question, the angular speed of cylinder is equal to twice that of angular speed of sphere. So 2 into angular speed of sphere. This is the condition given here. the angular speed of cylinder is twice of angular speed of sphere. Okay. The ratio of their kinetic energies of rotation E sphere divided by E cylinder we have to calculate here. So my dear champion, very good question. So do you know what is energy, kinetic energy of a sphere? Everyone knows. So if we write here kinetic energy of sphere, so do you know the kinetic energy of sphere will be equal to half I of sphere and omega of sphere whole square, right? Inertia, moment of inertia of sphere, but you cannot write here the moment of inertia directly 2 by 5 mr square, because you have to focus the condition also how the sphere is rotating. So the sphere is rotating about its diameter. So about its diameter, it means that the axis of rotation is passing from the center, which is same 2 by 5 mr square. So let's write it first. Now kinetic energy of cylinder will be equal to half I of cylinder into omega of cylinder whole square, and we have to find out the ratio. So can we please divide these two? So if we divide, half cancel here, and is means moment of inertia of solid sphere, which is equal to 2 by 5, and omega s square we can write directly omega s square divided by IC means moment of inertia of cylinder, and moment of inertia of cylinder we all know 1 by 2 mr square. So this is equal to 1 by 2 mr square. We can also write mr square here. See, the solid sphere of mass m and radius r, same mass and same radius r. So just here, this is here 2 by 5, we forgot here, m, and this is r square and omega of sphere square divided by 1 by 5 m r square, and this is omega of what? Cylinder, and omega of cylinder is 2 into omega of this sphere. So can we please cancel here? So this will be cancelled here, mr square will be cancelled by mr square, and this is omega s square. So this is equal to 2 omega s square, omega. So this will be equal to 2 omega s whole square. So 2 to the 4 will be there. So we are getting here 2 by 5 divided by 1 by 2 into, and this is equal to what? Omega square will be cancelled and 2 square will be 4. So 4, can we write this? 2 into 2 divided by 4 into 5. So 2 cancel here. So this is equal to 2 by 10. Any option is there? Which option is correct? So 1 by 2 mr square, I omega square, half I omega square. This is half. This is what, my dear champion? We have ignored half. Half will also come here, no? Half will also come here. So just do it again, I think. So mr square cancel here, and this 2 will cancel here. So we are having, so do this again, I think some mistake. So do it again, some basic mathematical calculation. So can we do again here? Yes. So this is 1 by 2 and the moment of inertia of cylinder, so a sphere which is equal to solid sphere, 2 by 5 mr square, and I omega, half I omega square, so omega s whole square divided by 1 by 2 cylinder, 1 by 2, and moment of inertia of cylinder is equal to mr square by 2. So this is 1 by 2 mr square. 1 by 2 mr square. Can you see here? Here this is solid cylinder, that's why mr square by 2. Okay, and here omega of cylinder, and omega of cylinder is twice. So 2 omega square, that will be 4 into omega s whole square. Now whatever cancelling here, just cancel all those things. Half cancelled here, mr square cancelled here, and this will cancel here, and 2 will cancel this. 2 will cancel this, right? So we are getting here 2 by 5 and divided by 2 bunch. So this is 2 by 10 will cancel by 5. So 1:5 is correct answer, option number B. Just basic calculation is there. Any problem to anyone? Hi sir, hello everyone. So there is just mathematical calculation, champion. Anyone, any problem to anyone, just let me know. Any problem to anyone, please let me know. Yes. Is it clear to all? If you know the formula, you can get the answer. If you don't know the formula, you cannot solve at all. Yes, bro, yes. Shiva, the silly mistake, it happens, bro. What you're spamming there, you're writing same thing again and again. It happens. Now we forgot 1 by 2 here. And we know kinetic energy is having 1 by 2. So we forgot 1 by 2. This is not a big deal, bro. Stay chill, bro. Thank you so much. Hello, champion. Yes, sir, clear. Is it clear to all, Shiva? Don't write same thing again and again. It looks so irritating. You know, we are human beings. Happens. It happens. Sometimes it happens, bro. So we just forgot to 1 by 2 because we are talking about kinetic energy. So kinetic energy is having 1 by 2 also. 1 by 2 is different thing and moment of inertia is different thing. And moment of inertia of a sphere is 2 by 5 mr square, solid sphere is there. And moment of inertia of cylinder is 1 by 2 mr square. And this is solid cylinder. Clear? Clear to everyone? Tarun, Chiru, Shiva. Yes, Shiva, is it clear? So why you have written there same thing again and again? Go and delete that. Don't write such things again and again. Okay, Chiru. No, just chilling, bro. Just I want to keep this environment very fun-filled and alluring because you all are superb guys. And I know lot of challenging thing, lot of difficulties that you have surrounded by because it's all about your NEET exam and you have only 10 to 12 days. I know you all are tensed about your exam. You all are having a lot of anxiety, pressure, stress and all. So just love from my side, everyone. You all are superb here. How sweet of you, everyone. Is it clear to all? 1:5, is it clear? Moving to next question, question number 9. Wow. This one is important question and such similar questions comes in JEE also. JEE means not advanced, I cannot say for advanced, but yeah, JEE means, in JEE means such question comes up. So this question is important for KCET students and NEET, very important for NEET. And as I can imagine, I can guess, as per my experience, as per my expectation, there may be one question based on this theory. When from a solid structure some part is removed, so what will be the moment of inertia of the remaining part? This is very important. So just chill, sir. I always used to be very chill, Tarun, always. And after meeting you guys, some more. Okay, so this is very important. So I think who can solve this question comfortably? Tell me. Let me know your name. Give me thumbs up. Yes, sir, I can solve this question very easily. This is nothing for me. Sir, correct option is A. Okay, just wait a little while. Pandurong is writing option number A. What about others? Very important question. So, okay, let's solve the question. A sphere of radius r is cut from a larger solid. A sphere of radius 2r, okay. So the bigger sphere, the largest sphere is having radius 2r. So what will be the radius of this small sphere which is removed is a small r. Okay. The ratio of the moment of inertia of the smaller sphere to that of the raised part of the sphere about y-axis will be what? Very good question. So in this question, we have to find out the ratio of moment of inertia of the smaller sphere. Okay. So I smaller divided by the moment of inertia of remaining part, the moment of inertia to the rest part. So what will be the moment of inertia of rest part? I have already told you the formula how we can find out the moment of inertia of rest part. So moment of inertia of rest part will be I original before removing anything minus I of this smaller sphere. So that will be moment of inertia of remaining part, na? I original minus I of removed part. And which is removed? Which has been removed? Smaller part. So I can write here this. So in this question, we have to find out this. What will be the answer of this? This is the question. I hope you have understood the question. So Sir, my name is Jayalakshmi. Very good, Jayalakshmi. Thank you so much for letting me your name. Thank you. Sir, very easy. Suhana is writing very easy. Superb, you are. Wow. Superb. Very good. Okay. Okay, so let's solve. Focus here. I'm solving this question for all the students who don't know how to find the answer, who is having little bit problem still. So I'm solving for all those students because each one of you student is important for me. So let's find out. So what will be the moment of inertia of this smaller sphere? Focus on this first. So can you find, and we have this, we should not ignore here y-axis. We have to find out the moment of inertia along y-axis. So for this y-axis, for a smaller sphere, can you see here, this will be the center. This will be the center of a smaller sphere. This will be center of the smaller sphere. So what will be the moment of inertia of the smaller sphere? Can we apply here parallel axis theorem? Yes, we have to apply here parallel axis theorem. So the moment of inertia of smaller sphere will be equal to, first is moment of inertia of this whole sphere, and this is also solid, so this will be equal to 2 by 5 m. What will be the mass of this smaller sphere? The mass of this smaller sphere will be equal to m by 8. M by 8 will be the mass of this smaller sphere. If any one of you having any problem, so let me show you how this m by 8 came. Listen, my dear champion. So if we talk about density of this whole body, density of whole will be equal to density of this smaller. Look, just learn the concept of physics. Density will remain same because this is one single body, and from that one single part, this small part is removed. So the density will be similar. Do you know density? Density is equal to mass upon volume. Density is equal to mass upon volume. So density of whole can be written as mass of whole body upon volume of whole body, which is equal to 4 by 3 pi 2r cube. 4 by 3 pi, the volume of original, this is 4 by 3 pi 2r cube, right? And this smaller, the mass, we don't know the mass, we want to calculate, so this is m dash, let's say. And what will be the volume of this sphere? 4 by 3 pi, and r, 2r is the diameter, so the radius of a smaller part will be small r, r cube. So 4 by 3 pi r, 4 by 3 pi cancel, and this is m divided by 2r cube will be equal to 8r cube, and this is m dash divided by r cube. And can you see r cube cancel, so m dash is equal to m by 8. M dash is equal to m by 8. I hope this is clear to you. That's why I have written there m by 8 is the mass, right? So I smaller will be 2 by 5 m by 8 r square, 2r is the diameter, so this is plus, because we want to calculate here moment of inertia along this y-axis, right? So what will be the distance from y-axis? This will be the distance from y-axis r, so that moment of inertia will also be added there. So m by 8, and this is r square. You know parallel axis theorem, so we have applied here parallel axis theorem. So can we please solve this? So after solving this, let's solve here. So this is 2m divided by 8, this is 8 5 is 40, and this is r square. 2 by 8 5 is 40, mr square, plus this is m by 8 r square. So this will cancel here, 20. So after solving this, can we take here mr square common? So by taking mr square common, we are getting here 1 by 20 plus 1 by 8. So let's take the LCM. So mr square, and taking the LCM of this 20 and 8, I think this will be 40. 40 will be the LCM, right? So 22 jar, and this is 8 5 jar. So we are having 7 by 40 mr square. This is the moment of inertia of smaller one. Let me show you by covering this in a box. This is the moment of inertia of a smaller one. Now let's talk about the moment of inertia of original one. So what will be the moment of inertia of original? Nothing, champion, nothing, champion. The original is this, having capital mass, and m, this is solid. sphere is there. So 2 by 5 m, but radius of the original one is equal to 2r. So we have to put here 2r square. So can we solve this? 2 by 5, and this is m, and this is 2r square will be equal to 4r square. So we are having, this is 8 by 5 m r square. Now you have I original and you have I smaller. Now can you find out this? Yes, nothing left. So let's find out the difference of I original and I original minus I smaller. I smaller will be what? I original is 8 by 5 mr square, minus this is 7 by 40 mr square. So can we take here mr square common? So by taking mr square common, this is 8 by 5 and this is 7 by 40. 8 by 5 minus 7 by 40. Now take LCM. So this is mr square, and by taking LCM 5 and 40, the LCM will be 40. So this is 5 8 ja 64. 64 minus this is, and this will be 7. So this is 64 minus 7 will be what, champion? 64 minus this, that will be 57. 57 by 40 mr square. This is the difference. It means the moment of inertia of remaining part. Now you have all the values put here. So let me use yellow color. So let's use yellow color. So I smaller is what, my dear? I smaller is 7 by 40 mr square divided by the difference. I mean the moment of inertia of remaining part is equal to 57 by 40 mr square. 57 by 40 mr square. mr square cancel, 40 cancel. So we have 7 by 57, which is equal to 7:57. This is the answer. Answer 7:57. Any option? Option number A will be correct. Yes, take a screenshot everyone. Screenshot, please take a screenshot of this solution. Take screenshot of this solution. So this is the moment of inertia of smaller part, and the moment of inertia of smaller part will be 2 by 5 m by 8 r square plus mr square, because we want to find out the moment of inertia along this y-axis. So here we have applied parallel axis theorem. Please keep it in mind. Here we have applied parallel axis theorem. Because the axis which is passing through the center of a smaller sphere is parallel to this y-axis. So we have to apply here parallel axis theorem. Clear to everyone? Clear to everyone? I hope the doubt is now clear for everyone. So please keep it in mind, the moment of remaining part, the moment of inertia of remaining part is equal to the moment of inertia of original minus moment of inertia which is removed. And here the removed part is smaller sphere, and that is why we are writing here I smaller. I hope this is clear to you everyone. Okay, so you guys are enjoying this session? You all are now feeling confident? Is it helpful for you all? Do you think this session is very helpful for you all? Please let me know this answer of this question, everyone. Do you feel this session is really helpful for you all? You all are enjoying? Your doubt is now clearing. Please tell me honestly, because your involvement encourages me a lot and give me strength to do something, to deliver something quality session for you all. So do you know, this question is very important, and this is from 2025. Yeah, tell me. Are you ready for the next question? Question number 10 for the session. Shiva is writing, sir, have some water. Thank you so much, Shiva, for your concern. Thank you so much for asking this. Okay. Please take a screenshot, and you should try this question again by your own when you do self-study. Lahari, thank you. Okay, moving to next question. And look, my dear, this question is from previous year question paper 2025. This is not so old question. So it might repeat this year also. The question may not be exactly same, but the pattern will be little bit similar. Okay, moving to next question. Okay, yes sir, Darsh, Rohit, hi Rohit. Thank you so much, champions. Okay, now look at the question. This question is from Mains 2012. The moment of inertia of a uniform circular disc is maximum about an axis perpendicular to the disc and passing through. Oh, so there are 4 spots, point A, point B, point C, point C, and this is uniform disc, and the question is asking if a line passing through perpendicular to the disc, passing through A, passing through B, passing through C, passing through D. So at which point the moment of inertia will be maximum? Sir, I want question paper. So Onryo, if you want question paper of this session, so you need to hit the description. There will be link given in description where you can get the question paper of this session along with the solution. This is the beauty of this session. Okay. Yes. At which point the maximum moment, this is a very easy question. See champion, just imagine if I am having a disc here and the moment of inertia of disc when the axis of rotation is passing through the center, which is equal to mr square by 2. Now if we are taking axis just beside of the center and the line is parallel to the axis passing through the center and that line is perpendicular to the plane of the disc, so just apply here parallel axis theorem. So just imagine, I cannot draw this figure in 3D, so just imagine a line passing through here B point. This is the first, and if the line passing through C, D, and similarly A is itself a center. So which point is at the farthest point from the center? Do you know, if you apply here the moment of inertia at point just A, so moment of inertia at point A will be mr square by 2 only. Why? Because A is itself the center. If you find out the moment of inertia at B, so that will be mr square by 2 plus m into this distance. Let's say this is x, so we have to write here mx square, right? If you find out the moment of inertia, the axis of rotation is passing through C, so this will be equal to mr square divided by 2 plus m, and let's say this is here, this distance is y, so this will be my square. And similarly moment of inertia at D, so this will be mr square plus D, and axis of rotation is passing through D, and this will be here, this small distance will be z, so this will be mz square. And can you please tell me in x, y and z which is the largest? Which distance is the largest? So x is the largest, the point B is the farthest from point, so here x is greater than, y is greater than z, so x is greater than, so if x is greater than, the moment of inertia of B will be maximum. So moment of inertia B will be maximum. B will be maximum for all. Okay, so which option? The moment of option number A. This is the answer. So this is the explanation. I cannot give answer randomly without concept, so I don't feel the giving you direct answer only without explaining the concept. I think this is not good methodology to teach. So I'm giving you here explanation as well. Yes, clear to everyone? Tell me, my dear champion, is it clear to all, everyone? Good. Okay, who answered option number A? Let me check it again. Okay, A is correct. Yes, Suhana, A is correct. You are absolutely correct here. I hope you have already subscribed the channel Diksha Karnataka. If you haven't subscribed the channel yet, go and hit the subscribe button as well, because this channel is dedicatedly, we are delivering quality sessions, quality classes, live, even lecture video, recorded video as well. So I think this will be very helpful for you. Yes sir, I'm cleared about it. Thank you so much, Larry. Yeah, thank you Vijay Lakshmi, thank you Suhana. Super. Ready for the next question? Moving to next question. Okay, what is this? This question is from previous year question paper. Wow, PYQ 2025. The sun rotates around its center once in 27 days. What will be the period of revolution if the sun were to expand to twice? So the size of the sun, just imagine the size of the sun has expanded twice its present radius without any external influence, without changing the internal influence, only radius, only size is increased. It means the mass distribution is still same. Assume the sun to be a sphere, uniform density. So I have already told you without reading the next line. The uniform density means the mass distribution is similar at every point. Okay, so we have to find out the time. This is based on angular momentum. Sir, already subscribe your channel 2 months over. Thank you. Very good, Shohana. Yes, everyone. Do you know who is this? Hi, Shohana. Vikas. Hello, Vikas. Yes. Which option will be correct? Do you know angular momentum? Angular conservation of angular momentum. So this question is absolutely based on conservation of angular momentum. Yes, my champion. So applying here angular of conservation of what, my dear champion? Conservation of angular momentum. So do you know I1 omega 1 is equal to I2 omega 2? And do you know one more thing? Omega is what? Omega is equal to 2 pi by t. And 2 pi by t is what? We can also write as 2 pi nu, which is called frequency. Nu is frequency. Nu is frequency. And we don't require to write here nu because we want time period. We have to calculate time, days. Options are in time, days. So we don't need to change this. We can directly write this. So I1 means before expansion. And we are considering this earth as what? Solid sphere. So moment of inertia will be equal to 2 by 5 mr square, and omega can be written as 2 pi by t1. And which is equal to, there t1 is 27 days already given. And now after expansion, the radius of the earth has become twice. The initial radius was r. Now the radius is increased by twice. So I2 can be written as 2 by 5. Mass will remain same, champion, and only size is increased. So this is equal to 2r square, and omega 2 can be written as 2 pi by t2. Right? See, the question is without any external influence. It means that the mass is same. Right? So 2 by 5 m, 2 by 5 m cancelled here, and 2 pi cancelled here. So we are getting here, this is r square. So r square divided by t1 is equal to, here this is 2r square. So 4r square divided by t2. Right, champions? So this is r square cancelled. We require t2. So t2 has become equal to t1 into 4. So t2 will be equal to, t1 is 27. And 27 into 4 will be equal to 108 days. Answer. This is the answer. Any option? Option number B will be correct. So this solution is based on conservation of angular moment. Who is this? Yes. If you search in Google, Lahari, I'm good. What you guys are talking? Okay, Karthik, is it clear? Shiva, champion, please focus on solution. Instead of talking with each other, I think you should focus on solution because you don't have a lot of time. And these questions are genuinely very helpful for you all, everyone. You have only 10 to 12 days for your final revision, champions. So don't talk, just focus here. Yes, is it clear to all? 108 days, Rohit, Vijayalakshmi, Karthik, Shiva. If anyone is having any kind of issue, problem, difficulty, challenge, just let me know. Otherwise, this is very easy question. Okay, sir. Very good. Sir, I will have my lunch and come. Kirti, please make sure to come fast and go and have lunch. Yeah, it's only, it's about 1:30, 1:40. Yeah, you guys required lunch. So let's take a break here of only 3 minutes. I think 3 minutes is enough for a student, for a dedicated. So I'm taking 3 unit, Newton's break. My break name is Newton's break. Okay, so Newton's break, honoring our great physicist Newton. So just take a 3 minutes break, champion, and make sure to come very fast. I'll be waiting for you all, because still we will have to do a lot of question here from system of particles and rotational motion. So go have some snakes, have some lunch, whatever you want, and come fast within 3 minutes. So thank you so much, everyone. I'll be waiting for you all. Okay, so you guys are back. Very good. Super. Just a second. Let me. The mic got strangled. Just. Okay. Now, are you feeling energetic? How to get rank without studying? What a question. Question of the era. Yes, Suhana, Karthik. Hi, champions. Hi, everyone. Hello everyone, let me check it again. Sir, don't give breaks, sir, don't give break. Okay, sir, we'll back in 3 minutes. You also have drink. Thank you so much, Karthik. Shiva is so energetic. Shiva said like, sir, don't take break. Can we start now to preparing? Yes, see Gayana, if you have some strong approach and you become dedicated, like even in just 10 days, if you utilize at least 4 hours every day. So 4 hours, how is it possible? If you utilize 4 hours in self-study, yes, champion, you can score even now good rank, good score. But you required short revision, quick revision, like PYQs. You don't need to go entire syllabus. You cannot revise entire syllabus. Sir, these are helpful for COMEDK. Absolutely very helpful. Such questions similar to Neet comes up in COMEDK and KCET as well. So all the KCET and COMEDK students, welcome here. Okay, shall we start? Yes, Larry, start. Moving to next question. Question number 12. Oh yes, Rohit. So a solid cylinder of mass m and radius r rolls without slipping. Come on, rolling, not slipping, rolling. It means that translational motion and rotational motion both will be there. So if this is not slipping, it's rolling, it means that there will be both motion, translational as well as what, rotational. So kinetic energy will be of both times. Rotational kinetic energy and translational kinetic energy. Sir, I am KCET for KCET live. Okay, yes, Kaina, you can stay here soon as possible because next I have to attend chemistry class 2 o'clock. Okay. So a solid cylinder of mass m and radius r rolls without slipping down an inclined plane. So listen, champion. So there is an inclined plane. This is the inclined plane, right? And there is a cylinder. I cannot draw in 3D. So the cylinder, the cross section of cylinder is visible to you all. It is rolling down. From height h. So this height is of h height. So my dear champion, if the cylinder is initially at some height, so which energy will be there? Here at this point, only potential energy will be there, which is mgh, right? Now it's rolling down, and this cylinder will reach to ground. We have to find out here what is the speed of its center of mass when the cylinder reaches its bottom. So we have to find out the speed of center of mass. So let's say at this point, when the cylinder will reach to the ground, the cylinder will having both energy, because cylinder is now in motion. It is in motion. So the cylinder is having both energy, kinetic energy rotational plus kinetic energy translational, and this potential energy will change in kinetic energy according to conservation of energy, right? So according to conservation of energy, just put the values. So kinetic energy rotational will be equal to half I omega square plus kinetic energy translational half mv square, which is the velocity of the center of mass, is equal to this whole potential energy, which is equal to mgh. Right, champion? Yeah, applying conservation of energy. So this small m will be cancelled. Oh, sorry, we cannot directly cancel here small m. Just first write the moment of inertia. So what will be the moment of inertia of cylinder? Solid cylinder. This is solid cylinder. So this will be m r square divided by 2, and omega will be replaced by v square by r square, because we know v is equal to r omega. So omega can be replaced by v by r, but here is square form, so that will go also in a square form. So half m V square is equal to mgh, right? So can we cancel here? M will be cancelled, M will be cancelled, M will be cancelled, right? R square will be cancelled. So we are having here only V square by 4, and this is plus V square by 2, and this is equal to GH. So can we take LCM here? By taking LCM, this will become 3V square by 4 is equal to GH, right? We have to find out the value of V. So V will be equal to, V square will be equal to 4 by 3 GH. So V will be equal to under root 4 by 3 GH. Answer. Any option is there? 4 by 3 GH. Option number C will be correct. Who answered here? Option number C. Sir, option C. Karthik answered option C. Kamlesh answered option C. Nima answered option C. Kamlesh C. Very good, everyone. Very good, champions. Option number C is correct. Under root 4 by 3. So I have solved this question just on conservation of energy. When the cylinder was at the highest point, it had only potential energy due to height, and this potential energy will change in kinetic energy. And as this is rolling, the body is rolling, so the body will have rotational kinetic energy as well as translational kinetic energy. I hope this is clear to you all. Tell me, everyone, is it clear to all? Moving to next question, question number 13. Consider a contact point P on a wheel on ground which rolls on ground without slipping. Without slipping means the wheel is rolling, the body is rolling. Then value of displacement of point P when the wheel completes 1/2 rotation. Okay, so the question is, listen here, the solution. Look at the question. The question is, there is a wheel, and let's say this is ground. There is a wheel, and consider a contact. So let's say this point is here, which is in contact with the ground, right? After, when rolling on a ground, when of a wheel on ground which rolls on ground without slipping, then value of displacement, what will be the displacement of point P when wheel completes 1/2 rotation? Champion, when the wheel completes 1/2 rotation, the wheel is rotating and it took 1/2 rotation. So in 1/2 rotation, the P point will come here, and the wheel has displaced to this point. So let's imagine this P point has reached to this here. This P point will be here. In half, this is initial point and this is final point, and this is all about 1/2 rotation. So what will be the displacement of the point? Displacement. So this will be the displacement of point. Can you see? This will be the displacement. Displacement means shortcut. So this will be the displacement, and this is the center. So if you join this point from here, oh my God, you are having a right angle triangle, and we have to find out here the displacement. So this line will show the displacement of P. So can we please find out the displacement of P? And do you know, in 1/2 rotation, if the wheel would have taken complete rotation, so what will be the total distance covered by the wheel in complete rotation? That is equal to circumference of the circle. But in 1/2 rotation, distance covered in 1/2 rotation will be equal to semi-perimeter, the half of perimeter, and the half of perimeter 2 pi. And what is the radius? Radius is not given, so we can directly take 2 pi r divided by 2, and 2 cancel, that is equal to pi r. So this is equal to pi r. This is equal to pi r, and this whole is equal to 2r, the diameter of the circle. So can we please find out the displacement? So displacement, the displacement will be equal to under root, because we have right angle triangle, and we can find out, we can apply Pythagoras theorem. So this is equal to pi r square plus 2r square, right? So r is equal to, here r is equal to, the radius of the wheel is 1 meter, so pi into 1 will be pi square plus 2 into 1, so this is equal to under root pi square. 2 square is 4. This is the answer. Pi square 4, and this is distance, displacement, so meter. Option number B will be correct. So in 1/2 rotation, the distance covered by the wheel will be equal to semi-perimeter. Clear to everyone? I know little. Okay. Hi everyone, is it clear to all? If you want to take a screenshot, you can take a screenshot of the solution and you can write the solution also in copy. Okay, B option is correct. Shazia, hi Shazia, I was waiting for you everyone. Karthik, you all are the old student, you have been attending my live sessions from the beginning, from the first live session. Shiva, Shazia, and a lot of students are there. Okay, is it clear to all, champion? So in half rotation, distance covered in half rotation is equal to half of perimeter. Distance covered in complete one rotation is equal to circumference, which is equal to 2 pi r. Clear to all everyone? Are you enjoying the session everyone? Very important. This is from Neet 2002. Question number 2014. Okay. A solid sphere of radius r is placed on a smooth horizontal surface. Okay. There is a solid cylinder and is kept on smooth horizontal. Do you know smooth horizontal surface? It means what? No friction is there. No friction is there. So a horizontal force F is applied at height h from the lowest point, okay, from the lowest point for the maximum acceleration of center of mass, which is correct. Wow. This question not required mathematical calculation, but this is conceptual question. If your concept is clear, if your physics is strong, you can answer this question. Otherwise, you cannot. Many students will mark a wrong answer here in this question because it looks very conceptual question. Yes, yes, sir. Yes, tell me which option will be correct here. Very important question. Very important. Which option will be correct here? Everything is here depends on this smooth horizontal surface. Do you know what is the difference between smooth horizontal surface and rough horizontal surface? If a solid sphere is moving, rolling, or whatever the motion is on rough horizontal surface, there will be friction. And if there is smooth horizontal surface, there will be no friction. This is the question. Yes, tell me which option will be correct here. Tell me. Option C? Who is saying option C? Yes, sir. Okay, very good. Option C, H is equal to 0. Okay. Rohit is saying option C. Karthik is saying option C. Lot of student is saying option C. MD is writing option B, H is equal to 2R. Did you understand the question, guys? Okay, so let me give you the clarity of the question. Here, the question is basically, this is surface, right? And this surface is smooth. And if surface is smooth, no friction is there. And if no friction is there, no rolling is there. Slipping will be there. No rolling is there. Please keep it in mind. If surface is rough, then only with the rolling, because the friction will lead the rolling motion. So if surface is smooth, no rolling will be there. Right? Now, a solid sphere, here is the solid sphere. This is the solid sphere. A horizontal force F is applied here. Here, F is applied at height h from the lowest point. So this is the lowest point which is in contact with the ground. And let's say the force F is applied here. This force, and this is the center. The force F is applied here at point h. At height h, the horizontal force. Then for the maximum acceleration of the center of mass, which is correct? My dear champion, if the motion is not rolling, not rolling, so whether you applied here force, here, anywhere, there will be no impact on acceleration. So for minimum and maximum acceleration, there will be independency of height. There will be no relation of radius and height. Wherever you apply the horizontal force, if rolling motion is not there, there will be no impact on acceleration. It means that no relation between h and r. Why? Because the surface is smooth. And if the surface is smooth, no rolling motion is there. So whether you applied force here at the bottom or at some height h, 2 meter, 3 meter, whatever, there will be no impact on maximum acceleration. This is the answer. Okay, sir, understood. Karthik, is it clear, everyone? Is it clear, everyone? Yes, Lahari, stay blazed, champion, stay blazed. Okay. Shiva is correct. Shiva is saying here option number D is correct. Yes, option number D will be correct. So I have already told you this question is a bit conceptual question. So this is conceptual. Conceptual question, not mathematical. This is just based on your knowledge, your clarity. What is the difference between slipping and rolling motion, perfectly rolling motion, partially rolling motion? What is the difference between rough surface and smooth surface? Simple. Okay, moving to next question, question number 15. Karthik, yes sir. Okay, what is this question? Two discs of same moment of inertia rotating about their regular axis passing through center and perpendicular to the plane of disc has angular velocity omega 1 and omega 2. They are brought into contact face to face coinciding the axis of rotation. The expression of for loss of energy during this process will be what? Wow, important question. Okay, but Rohan, you should not skip anything. You should not skip anything, my dear champion. And this is a very simple concept, no? This is not any rocket science and all. Very simple concept. Okay, we are solving here PYQs. Okay, now solve this question. Very important. Two discs of same moment of inertia rotating. Just read the question carefully, calmly, and draw the situation. Sir, option number A is correct. Shiva is writing option. Let's wait for others. I'm waiting for others' response. A lot of students are watching the live class here. Let's wait for others. Hello. I'll be calling you later. Go to my son. Thank you. Okay. Yes. Which option will be correct here? Sir, option A. See, in this question, we have to find out the expression for loss of energy. How we can find out the expression for loss of energy? That is basically change in energy. So basically here, loss of energy will be equal to what, my dear champion? Final kinetic energy minus initial kinetic energy. This is all about. So we have to use your formula directly. Yes, who is this? Nagendra. Nagendra is writing option B will be correct. Shiva is saying option A. Sir, option A correct. B, how B is the answer? Try it once again, please, everyone. Try it once again. Try it once again, everyone. Very important. See, I is a moment of inertia basically. Shiva is Nimma. One more new option has arrived here. Option number C. So you looks very confused, guys. How someone is writing option A, someone is writing option B, and someone is saying option number C. Read the question carefully. Read the question carefully. Sir, A is correct. I will also go to majority. A. 1/4 I. Okay. Vijay Lakshmi is writing option number. Sir, A will be correct. I think also A, because 1/4 will obviously come there. So, okay, look at the question here. Okay, look at the solution. Okay, so I have already suggested you read the question carefully. Two disks of same moment of inertia are rotating about their angular momentum, about their regular axis passing through the center, right? And perpendicular to the plane, right? Disk has angular velocity omega 1 and omega 2. They are brought in contact after some time. Both the disks have brought in contact, and after combining, now they both are rotating, so the angular velocity will be common because now the disks have brought in contact with each other. So what will be the angular initial energy and final energy? You have to find out that value. So listen, my dear champion. Okay, so initial energy minus final energy. So find out initial energy. So if we talk about here, do you know conservation of angular momentum? So after applying conservation of angular momentum, listen champion, conservation of what? Angular momentum. So what is the initial situation? Initial situation in which both the disks are separated from each other. So I1, moment of inertia is same, no? Same moment of inertia. So I omega 1 plus I omega 2. This is the total angular momentum before bringing them in contact with each other. After bringing contact with each other, that will be I. Moment of inertia will remain same, and omega will also be same because now both the disks are in contact with each other. But the final moment of inertia, who is this? Option D. Nima is saying option number D. Let's wait a little while. I'm solving here. So my dear champion, this is all about, now when you are bringing contact with each other, both the disks, so that will be equal to 2 and omega will remain same, so 2 I omega. Why? Now both disks are in contact with each other, so can we find this? So can we take I common here? So this will be omega 1 plus omega 2 is equal to 2 I omega. 2 I will cancel, so omega will be equal to omega 1 plus omega 2 divided by 2. This is the final angular velocity after coming in contact with each other. Now what will be initial energy? That will be half I omega 1 square plus omega 2 square. So we can write combined form, omega 1 plus omega 2, omega 1 square, half I1 omega square, omega 1 square plus omega, minus 1 by 2. What will be the inertia? Inertia is 2I, na? So we have to write here. Yes, everyone, any problem to anyone? Who is this? Shiva. Yeah, D might be correct, bro. So just look at the solution. So EF 1 by 2 I will be what, my dear champion? 2I. And what is the omega square? Half. So we are using here the energy. The formula of energy is half 1 by 2 I omega square. This formula we are using here. So what will be I? Omega is V omega 1 plus omega 2, omega 1 plus omega 2 divided by 2 whole square. Okay, just solve this. So 2 will cancel here, and we can take here common. So I will come out common, only I will come out common, and this is omega 1 square plus omega 2 square divided by 2, and here minus, this is omega 1 plus omega 2 whole square divided by 2 square will be 4. This is all about, right? So now can we solve here? So this is, can we take LCM? LCM will be 4. So 2 to the 4, so this will be 2 omega 1 square plus 2 omega 2 whole square. This is 2 omega 1 whole square. This is 2 omega 2, 2 omega 2 whole square, and this is A plus B whole square. Can we open the bracket? A square. So this will go in negative form. B square, this will go in negative form. Plus 2AB, that will also go in negative. 2 omega 1 omega 2. 2 omega 1 omega 2 divided by 4. Now which is cancelling here? No, nothing is cancelling, but we can write one thing here. 2 omega 1 square minus omega 1 square, that will be omega 1 square, plus 2 omega 2 square minus omega 2 square, that will be plus omega 2 square, right? And minus 2 omega 1 omega 2. So this will be 2 omega 1 omega 2. And can you see here, my dear champion, this is a square plus b square minus 2ab, and this is algebraic identity, a square minus b square, a minus b whole square. So this is I by 4 and omega 1 minus omega 2 whole square. Any option is there? 1 by 4 I, yes. Option number 2 will be correct. 1 will be correct. Yes, option number A. Who answered option number A? Shiva, option number A will be correct. So we have to find out here the expression for loss of energy, right? So loss of energy will be EI minus EF. When the body are separated from each other, the energy will be higher, and when the discs are coming in contact with each other, the energy will go down. So initial energy is greater and final energy is lower. That's why we are subtracting final from initial. Yes, clear to everyone? Clear to everyone? Any problem to everyone? Please let me know. Any problem to anyone? Your doubt is clear? Yes. Should I move ahead to the next question, champions? Let me know. Moving to next question. Question number 16. A thin rod of length L and mass m is bent at its midpoint into two halves, so that the angle between them is 90 degree. Yes. Hi, Mahalakshmi. 90 degree. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane will be what? So basically the question is, let's assume I'm having this rod. Let me take one more pen I required. This is here, my dear champion. I am having this one pen. Let's imagine this is a single pen. This is single rod, and this rod is now bent this form, like both are at 90 degree with each other. Can you see here? Both are at 90 degree with each other, and now this both is rotating this way, and the axis of rotation is passing through this corner, the point of contact, the corner, and both the rods are rotating in this way, right? So we have to find out here the total total moment of inertia. So listen, champion. So one rod is here, right, and one more rod is here. Both are at 90 degree with each other, and axis of rotation is here. Okay. Now, if the length of thin rod was capital L, so what will be the length of this half? This will be L by 2, right? And this will also be L by 2, right? And this is the point of bending. Right? And there is, let's imagine there is an axis passing through point of bending. The moment of inertia, the bent rod about an axis passing through the bending point and perpendicular to the plane, what will be? My dear champion, if the rod had total mass capital M, total length capital, so mass and length both will be distributed equally. So L by 2 and the mass will be M by 2. Length is L by 2 and the mass will be M by 2. So this is all about. Right. Now can we find out the moment of inertia? So the moment of inertia will be added up both. So we have the formula. So I net will be equal to what, my dear champion? Do you know this? The rod is fixed at this point, hinge at this point. So we have to use here ml square by 3. So 1 by 3, and m will be m by 2, and L square will also be L by 2 whole square. Plus similarly 1 by 3, and mass will be equal to m by 2. And this will be L by 2 whole square. Can we please multiply directly 2, because both are same, so we can multiply 2. So 2 into 1 by 3 into m by 2, and this is L by 2 whole square will be equal to L square by 4. So this 2 will cancel, and the answer will be ml square by 12. Any option is there? ml square by 12. Option number D will be correct here. When the rod is hinged at one end, so we generally use, this is the moment of inertia. When the rod is hinged at the end and this rod is rotating this way along this, so this is the moment of inertia. If the rod having length L, so ml square by 3. This is the first situation. And if a rod is rotating by considering this as axis of rotation, means this way, so and the length of this rod is capital L, so the moment of inertia for this situation is equal to ml square by 12. Please keep it in mind. This is the moment of inertia for this situation, and this is the moment of inertia for this situation. I hope everything is clear to you all. Yes, is it clear to all? My dear champion, the student who have joined newly and those who all are new here on this live session, go and press the like button, hit the like button everyone. Few likes are there, so go and hit the like button, and if you haven't subscribed the channel yet, please subscribe the channel. Okay, moving to question number 17. What is this? A wheel having moment of inertia 2 kilogram meter square. Okay, so moment of inertia of wheel is equal to, in magnitude, 2 kilogram meter square. Okay, about its vertical axis rotates at the rate of 60 rpm. Okay, if it rotates at the rpm, rotation per minute, so this is basically frequency, champions. So this is frequency, 60 rpm. So my dear champion, if this is 60 rpm rotation per minute, this is not SI form. So if we talk about rotation per second, 60 rotation in 1 minute means, it means that 60 rotation in 1 minute, it means that 1 second, 60 second. 60 rotation, 60 second. So how many rotation will be in 1 second? 60 will be cancelled here. So 1 rotation per 1 second. 1 rotation per 1 second. So if we talk about RPM, so we can also write this as RPS, 1 rotation per second. This is the frequency. I hope this is clear to you all, champion. Rotation per second is the SI format for frequency. Rotation per minute is not. Okay, about its, so frequency, the torque which can stop the wheel rotation in 1 minute. Oh my god, what a question. So we have to find out the torque. Do you know torque, the formula of torque is equal to I alpha, right? That formula for torque is equal to I alpha, and we don't know alpha. First we have to find out the alpha, angular acceleration, when the wheel will be stopping out. So we have very important formula. You know, we are stopping the wheel. So do you know we have formula omega square is equal to, or we can directly write in simple, first equation of motion for rotational motion. Omega is equal to omega naught minus alpha t. Why minus alpha t? Why minus alpha t? Because we have to stop the wheel. So the acceleration is deaccelerating, retardation is there. We know omega is equal to omega naught plus alpha t. This is the formula of first equation of motion for rotation. But the wheel is stopping, so acceleration is going down. So that's why the acceleration will go in negative form, right? Now, omega is what? Final velocity. We want to stop it, so this will be 0. And this is omega naught. Do you know omega naught? What is omega naught? We know omega naught. Omega naught can be written as 2 pi nu naught. Wow. Omega is 2 pi naught minus alpha into t. So alpha t will go there, alpha 2, and this is 2 pi, and new frequency is 1 pm. So this is, just write it down, 1. Okay, so what will be alpha? Alpha will be equal to 2 pi nu divided by time. We can put here, we can bring here. So this will be torque is equal to I, and I is equal to 2 kilogram. So this is 2 into alpha is equal to 2 pi into nu node is 1 divided by time. Time is how much of time? 1 minute. So time is 1 minute means 60 seconds. 1 minute means 60 seconds. So we have to put here 60. Can we please solve it? So this will be cancelled by 30. This will be cancelled by 15. So torque is equal to pi by 15, and torque we all know Newton meter. Any option is there, champion? Pi by 15 Newton per meter, option number C. Look at the solution. The way I have solved the question. This is just magic. Pi by 15. So I hope you have understood, right? We want to stop it. So the final velocity will be 0. And omega naught can be written as 2 pi nu naught. And nu naught is what? Frequency. Nu is frequency. We have frequency here. We have frequency here, RPS. Clear, everyone? Clear? This question is clear to you all, champions? Is it clear to all? Any problem? If anyone is having any kind of problem, difficulty, please let me know. I can repeat this solution again. Okay, moving to next question. Okay, so light rod of length L has two masses M1 and M2 attached to its two ends. Okay, so there is a rod. This is rod here. Okay, and length of L, very good. This complete length is L. This complete length is L, and here at this point, M1 mass is attached, and at this point here M2 mass is attached. Very good. Two ends. The moment of inertia of the two systems about an axis perpendicular to the rod and passing through the center. Very good. So there is a axis here which is passing through the center, and we have to find out the moment of inertia if the rod is passing in this way. Very good. So let's assume this is L1 and let's assume this is L2. Right, my champion? Let's assume this is L1 and let's assume this is L2. And we have to find out the moment of inertia of the system about an axis perpendicular to the rod. Very good. So my dear champion, if we are considering M1 which is at distance L1 from the axis and M2 which is at distance L2 from the axis, right? So L1 plus L2 here, L1 plus L2 is equal to L. So L2 can be written as L minus L1. I hope till here nothing is challenging. Right. Now apply here the center of mass. We have the formula to calculate the center of mass of any object. Yes, if any one of you is solving this question, please let me know what would be your approach here. What to do after this? Why I have written this L2, L1 minus L1, and what is the importance of this diagram? Please let me know. I'm waiting for the response. Which option will be correct here? Everyone. Yes, Shiva, lot of students are there. Yes, tell me everyone, which option will be correct here? Don't panic, just read the question carefully. We have to find out here L2. Once you get L2, nothing is there. Which option will be correct, everyone? Shiva, Nimma, tell me which options will be correct here. Hi Rohit, hi everyone. Very easy, very easy. We have to find out here L2, and once you get the L2, nothing is challenging here in this question. Nothing is challenging here in the question. Tell me. I am waiting for your response. Which option will be correct? Yes. Diagram is everything in this question. Diagram. If you have understood the diagram, nothing is left in the solution. Try it once again. Please try the question. Find out the center of mass. Where the center of mass will be lying. Come on, champion, come on. Find out the center of mass. Find out the center of mass on x-axis. If we consider this wire as x-axis, so how we can find out the center of mass? Yes, yes, Rohit, Shiva. Okay, so let's do. Let me give the solution. I was waiting for you all. So first find out the center of mass. So if we consider the center of mass is here for x-axis L1, so can we write for L1, we have you know formula, this formula, let me give you here. X is equal to m1x1 plus m2x2 divided by m1 plus m2, right? Same formula, bro. This is XCM. So M1, if we are considering M1 here, so M1 into 0, because this M1 is at here. We are considering this x-axis. Right? Plus M2. M2 is there. And what will be the distance of M2 from this point? this will be complete L. So M2 into L divided by M1 plus M2. So L1 will be equal to M2L divided by M1 plus M2, and once you get L1 you can find out L2 here. So L2 will be equal to L minus L1, which is M2L divided by M1 plus M2, right? Now L2 can be LM1 plus LM2 minus M2L divided by M1 plus M2, which will be cancelled. M2L will be cancelled, so L2 will be equal to M1L divided by M1 plus M2. So we have L2 here, we have L1 here. Now we have to calculate here moment of inertia of the system. So now what will be moment of inertia? Inet will be equal to moment of inertia of this L1. So M1 L1 square plus M2 L2 square, and we have L1 here. L1 is equal to this whole family, this. So this is M2 L divided by M1 plus M2 whole square, plus this is M2, and L2, here is L2, M1L divided by M1 plus M2 whole square. So can we please solve this? So this is M1 M2 square L square and divided by M1 plus M2 whole square, and here this is M2 and this is M1 square L square divided by M1 plus M2 whole square. What we can take common, champions? Can you see here? M1 M2 L square, M2 M1 whole square, and this is, so what we can take common? So here we can take common, I think M1 is here, M1 is here, so M1 can be taken as common. M2 square M2 can be taken as common, and L square is present in both, L square divided by this is M1 plus M2 whole square, M1 plus M2 whole square. So what is left here? Left behind is M2, so this is M1 plus M2, and my dear champion, M1 plus M2 will be cancelled by this, so I net is equal to M1 M2 L square divided by M1 plus M2. Any option is there? M1 M2 whole square divided by, yes, this option number A will be correct. Who answered here option number A? Anyone who answered option number A? Anyone is there who answered option number A? Let me check it once. 4. Apeksha, very good. Sir, option A is correct. Very good, Shiva. Perfect. I was waiting for your response, guys. Yes, perfect. Option number A is correct. Apeksha is right. Sharmila, no, Sharmila, option number B is not correct. I think you made some mistake anywhere. Just repeat the solution once again. Sir, D option. Vijay Lakshmi is saying option number D. Very good. Who else is there? Okay. Yes, guys. Who D will not be correct, Vijay Lakshmi. Option number A will be correct for this question. Okay. So this is all about. So in this question, the most important thing was to find out L2, because we required L2 for this moment of inertia. This is the axis of rotation, guys. This is the axis of rotation, AOR, right? So after finding out L1 and in the terms of L, because all the options are in terms of L. So we want to calculate L1 and L2. We have to convert L1 and L2 in the format of L. That's why we can get then only we can get the option which is relatable. So L1 in the terms of L, we have find out here, calculated here, and after putting the value of L1 here in this format, we got L2 again in the form of L, which is required, and after getting L1 and L2, we can here apply the formula. Thank you so much for watching. And I was looking out a question which is not present in this session, because we have done with all the questions. I was looking. Okay, don't worry, we'll be doing that question in next session. Thank you so much for being here. Thank you so much, everyone, all the NEET aspirants, future doctors. So we have done with this today's session. That was fabulous. Sir, I have said the yes, Viresh, Shiva. Okay. So the student who haven't pressed the like button, go and hit the like button, and I'll be looking forward to catch you everyone in our next session, and that will be most probably of oscillation and waves or electrostatics from class 12 PUC second year first chapter electrostatic, which is having good weightage in NEET exam. Lot of question comes up from electrostatics. So I'll be looking forward to catch you everyone. Stay blessed, stay sparkling, and take care of yourself, take care of your health, follow your good diet, and follow your parents also. Yes, champions. So thank you so much for watching. Thank you.